Hello students. So today discussion in chemical bonding we are going to discuss about hydrogen bonding, metallic bonding as well as some bond parameters like bond length, bond angle as well as bond energy. So first of all, to start the discussion with hydrogen bonding. So students, what is hydrogen bonding? So in the last video we discussed about polar covalent bond. Yes or no students? So what is polar covalent bond? There is a relation between polar covalent bond as well as hydrogen bond. Why? Because what is polar covalent bond? In polar covalent bond, students, the difference between the combining elements in terms of electronegativity. That means if a highly electronegative element combines with less electronegative element, then what happens to the electron cloud, students? Electron cloud shifts more towards the electronegative element or not, right? Correct. If the electron cloud is more towards the electronegative element, so what does it end up with? A partial negative charge. And what about the opposite element? It ends up with a partial positive charge. Ultimately, these polar covalent compounds, they have these partial positive charges as well as partial negative charges. So what happens if they have the partial positive and negative charges? In anywhere in general, only one molecule exists. No, in a sample, many molecules exist. For example, you are drinking water, only one water molecule is there. No, many are there. Ammonia is just a fertilizer, only one molecule is there, many are there. Hydrochloric acid, we are doing experiments HCl, are we doing with only one molecule? Many molecules are there. That means every molecule is surrounded by many molecules. So in the presence of these partial positive and negative charges, so they develop some kind of attraction between the partial positive charge and partial negative charge, and this attraction in terms of hydrogen bonding, that means if it is a hydrogen bond, definitely in the molecule which is compulsory, hydrogen is compulsory. So hydrogen, when it combines with highly electronegative element, now hydrogen gets which charge, students? Partial positive or partial negative? Partial positive charge. And the electronegative element gets which charge, students? Partial negative charge. Yes sir. And if in the case of many molecules, the weak electrostatic force of attraction between the hydrogen atom and the highly electronegative element of in the other molecule, this attraction is called as hydrogen bonding. Why highly electronegative element? Highly electronegative element gets a partial negative charge, hydrogen has a partial positive charge. Definitely there is attraction or not between positive and negative. This attraction is indicated by dotted lines, and this bonding is called as hydrogen bonding. Because if this bonding, it doesn't form any significant chemical change, but this is the reason for many properties for a molecule, students, which we will discuss in the characteristics of hydrogen bonding. So got the clarity? So if you want to define hydrogen bonding, what is hydrogen bonding, students? Hydrogen bonded to a highly electronegative atom such as like fluorine, oxygen or nitrogen by a covalent bond. This is covalent bond only. Which covalent bond? Polar covalent bond. The electron pair is attracted towards the electronegative, so that it results in the formation of a strong dipole, opposite charges, partial positive charges and partial negative charges. So and weak electrostatic force of attraction will be developed, and this weak attraction is called as hydrogen bonding. Look at the example. For example, X indicates an electronegative element. Hydrogen is bonded to this electronegative element. So these partial positive and negative charges are indicated by this symbol delta. So on the electronegative element, what is the charge it will end up with? We end up with a partial negative charge or not? On hydrogen, what is the charge? Partial positive charge. So partial negative charge and partial positive charge. Now what will happen? There are many molecules, like I said. In these many molecules, definitely the partial positive is attracted towards the partial negative or not? Sir, students, there is an attraction. Sir, why they do not attract in between there is an attraction also. But attractions are there as well as the repulsions are there between the nucleus and nucleus. Yes or no? That's why in general, while defining this attraction of hydrogen bonding, we used to mention between hydrogen atom of one molecule and electronegative element of another molecule, and this attraction is indicated by a dotted line, you can see clearly. So this bonding is called as hydrogen bonding, students. The electrostatic force of attraction between a partially positive charged hydrogen atom of polar molecule and a highly electronegative atom of the same or different molecule is known as hydrogen bonding. So what are the conditions for the formations of this hydrogen bonding? The atom which is bonded to the hydrogen atom must be highly electronegative. Yes or no? What is electronegativity? The tendency of an atom in order to attract the electrons towards itself is called as electronegativity. What is electronegativity? The tendency of an atom in order to attract the electrons towards itself. If electronegativity is more only, then it can show the significant attraction. So definitely for the existence of this hydrogen bonding, what is compulsory? Hydrogen should bonded with highly electronegative element. That is first condition. Next, the electronegative atom which is bonded to the hydrogen must have smaller size. Size also one of the factor. Why? Because students, if it is a small size, what is more for the small size? Effective nuclear charge. Yes or no? Fluorine, iodine, both belong to the 17th group element, but which can show higher attraction? Fluorine only. Why only fluorine? Why? Because fluorine atomic size is very less, 2s to 2p5 configuration. So because of smaller size, the valence electrons are more closer to the nucleus or not? That means the valence electrons also experience much nuclear force or not? The incoming electron also experiences more nuclear force or not? Yes, that's the reason. So that's why smaller size atoms can attract with more intensity. Why? Because their effective nuclear charge is more. Why? The valence electrons are closer to the nucleus. That's why. So smaller size, then only it can show higher electronegativity. Then there is a chance of formation of this hydrogen bonding. So the energy of hydrogen bond ranges from 12 to 60 kilojoules per mole. The energy of the hydrogen bond is less than that of covalent bond. Obviously, covalent bond is a perfect clear bond. The overlapping of atomic orbitals takes place. Yes, sir. No, that's a clear bonding. But hydrogen bonding is a weak attraction. So definitely it is less than the normal covalent bond. You can see the bond energies of this hydrogen bonding is given. Look at here, the values are given not between this and this. This is the normal covalent bond. These are the values for the dotted lines. Nitrogen atom of one molecule, hydrogen atom of another molecule, this attraction, hydrogen bonding. How much? 8.4 kilojoules per mole for this in the case of nitrogen, 29.4 kilojoules per mole in the case of oxygen, 42 kilojoules per mole in the case of fluorine. So what is happening to the bond energy? Left to right, increasing. Why? That means where it is more, in the case of fluorine or in the case of nitrogen, in the case of fluorine. What's the reason, students? Can you guess the reason? Right? Fluorine is more electronegative element and fluorine's atomic size is very less. That's it. Yes or no? If it is more electronegative, then what will happen? It can attract electrons more intensively. It can develop more partial negative charge, and the attraction between hydrogen atom and to the fluorine will be very strong. If it is a strong attraction, to break that attraction, definitely we need to provide more energy or not. That's the simple logic. More is the attraction, more is the intensity of the hydrogen bond. If more is the intensity, definitely to break that bond, you need to provide more energy. So in which case the bond energies are more? In the case of hydrogen and fluorine. Why? Because fluorine is small size and highly electronegative element. The bond length of the hydrogen bond is larger than that of covalent bond. What is the bond length? The distance between the two successive nucleus in a bonded situation is the bond length. Yes or no? So the oxygen hydrogen bond in water is approximately 1 angstrom units, and while hydrogen bond length is 1.7 angstrom units. So obviously clear. Why? In which case the bond length is more? In the case of hydrogen bonding. In the case of covalent bond, the bond length is very less. Why? Why? Because covalent bonded molecules, they share their electrons, they completely overlap with each other. In the process of overlapping, they come more closer with each other. Now the bond length increases or decreases if they come closer? The bond length decreases, students. So that's why, is this hydrogen bonding, are they overlapping? It is simply an attraction. So that's why the molecules are not that much closer comparatively with the other bonds. So that's why the bond length is also less comparatively with the covalent bonding. Now, what are the types of hydrogen bonding? We can expect two types, students. One is intermolecular hydrogen bonding, other one is intramolecular hydrogen bonding. Simple reason. Intermolecular means the hydrogen bonding exists between two molecules, two separate molecules. That is intermolecular. Intramolecular means it exists within the molecule. Intra means within the same molecule, hydrogen bonding can exist. Look at the intermolecular hydrogen bonding. Hydrofluoric acid, HF molecule. You can see the dotted lines. The hydrogen atom of one molecule showing attraction towards the electronegative element of the other molecule, fluorine. This attraction is called as hydrogen bonding. Is this attraction between the same molecule or with the other molecule? With the other molecule. And look at water examples also. Water is oxygen also highly electronegative element. Even water also contains hydrogen bonding, and I'll tell you one interesting point in the coming slide. So this is also intermolecule between the molecules. Ammonia, nitrogen, which is highly electronegative, so definitely develops a partial negative charge. Hydrogen develops a partial positive charge. they show the attraction. These attractions are called as intermolecular. And look at these. So here in this molecule, students, oxygen is there, hydrogen is there, and carbons, hydrogens, everything, all are there. Oxygen is highly electron wherever oxygen is there, which is bonded with the less electronegative element. It shows its electronegative character, not only oxygen, any electronegative element. If it combines with the other element which is less electronegative, it takes the electron cloud little bit closer towards it. Definitely develops partial negative charge. Similarly, same way here also, it bonds with carbon. Carbon is less electronegative, yes or no, than oxygen. So oxygen gets a partial negative charge, and here oxygen hydrogens are bonded by covalent bond. So which is more electronegative? Oxygen. So now hydrogen gets a partial positive charge or not? They will show attraction. The partial positive charge of hydrogen, partial negative charge of oxygen shows attraction, and this time this attraction is there within the molecule. That's why this comes under intramolecular hydrogen bonding. We can have other examples like orthonitrophenol, the same type, the same example, and orthofluorophenol also. We have the attraction between. This is not a bond, students, only attraction. That's why it is indicated by the dotted line between hydrogen and fluorine. That's a difference, simple difference between intermolecular and intramolecular hydrogen bonding. Look at some of the properties. All these points are very, very important. Properties explained by the hydrogen bonding. Molecules with hydrogen bonding possess high boiling and melting points than expected. Yes or no? What is happening? Molecules with hydrogen bonding possess high boiling and melting points than expected. Example, the boiling and melting points of ammonia, water, HF are high in comparison to the hydrides of other elements, the 5th, 6th and 7th group elements. I will explain the reason. What is the melting and boiling point, students? Melting and boiling points are the attractions between the molecules. In order to break those attractions, you need to provide some energy. Yes or no? We are not breaking the molecule, we are breaking the attraction only in order to convert a solid into liquid, liquid into a gas. Got the clarity? Now, if these hydrogen bondings are present, the attractions are more or less? Attractions are more. If the attractions are more, we need to provide more energy or not than the previous? Definitely more energy. Why? Because more attractions. If you want to provide more energy, now the boiling points increase, yes or no? Boiling points and melting points. So there is one fact about water, that is, because of this hydrogen bonding, H2O exists as liquid. Otherwise, it would have exist as a gas at room temperature. If it exists as gas at the room temperature, does the life possible, students? Do all we exist because of what the scientists are saying, like 4.6 billion years ago? The first life emerges. Yes or no? How the life forms? From where the first life emerges? From water. So because H2O from which state? From gaseous form or solid form or liquid form? Liquid form only. So this is the reason. This is the importance of hydrogen bonding. There are more attractions that makes the water H2O molecules to exist as liquid at room temperature. Otherwise it would have been in the gaseous form at room temperature. All these are might not be possible. Understood? Because of hydrogen bonding, molecules show more attraction. Attraction means what? Only attraction. Because of attractions, molecules move more closer. That's why liquid. Even more closer means that it is in solid. That's a different thing. Okay? Ultimately, if more attractions are there, to break those attractions, to break all these attractions, we need to provide more energy. That's why melting points and boiling points are more because of hydrogen bonding than expected. So unique property of water and ice are due to the hydrogen bonding. Density of ice is less than that of water, and water contracts when heated between 0 degrees Celsius to the 4 degrees Celsius. This is also very, very important point. This point is called as, comes under anomalous behavior of water or anomalous behavior of ice. I'll explain this point, students. Listen. Solid, liquid, gas. Which has more density? Ice. Solids, right? Solids have more density. If solids have more density, if we drop these solids in their respective liquids, these solids will float or sink. These will float, these will sink in general. Why? Because more density, na students? They will sink. Now let us take an example with H2O. What is the solid form of H2O? Ice. What's the liquid form? Water. Then ice should sink in water. But why ice is floating if it has more density? What is density? Mass per unit volume is called as density. Number of molecules per unit space is called as density. Why ice is floating? It should sink now. More density, right? More mass per unit volume. Yes or no? More is the mass means definitely it should sink. But why ice is floating in water? Because of this hydrogen bonding. And one more thing. If you try to heat the chemicals, the material, the substances, what will happen? They will expand, yes or no? But between 0 to 4 degrees Celsius, if you heat, the molecules of H2 are contracting, they are not expanding. The reason is, students, from 0 degrees Celsius, what is the melting point of ice? 0 degree. What is the freezing point? 0 degree, yes or no? So below 0 degree, water is converting into ice. At 0 degree, it is starting, and below 0 degree, it exists as ice. At ice, the molecules are not very close enough each other. Why? Because they have some hydrogen bonding. They have very strong hydrogen bonding. That's the reason why the molecules creates a space between them because of these attractions. These empty spaces, these vacuum spaces, or all these voids are all the reasons why ice floats on water. If there is a space, number of molecules per unit space are more or less? Less. Why? Because there is more empty space. So why there is more empty space? Why? Because strong hydrogen bonding and very less energy. And in water also hydrogen bonding is there, but in water there is little bit more energy. Are the molecules are structurally arranged in water? No. But the molecules are structurally arranged in ice. That's why that creates a spaces because of this hydrogen bonding, and these spaces are the reason why the density of ice is less than water. That's why ice is floating in water. Now listen carefully. From 0 to 4 degree, that means are we increasing the temperature, reducing the temperature? 0 to 1, 1 to 2, 2 to 3, increasing the temperature. If you increase the temperature, these molecules would expand, yes or no? But what the point saying? They contract. Why they are contracting? I already have told you. In ice, all the molecules are arranged by creating some spaces, right? So if you're increasing the temperature from 0 degree, what happens? All the force of attraction will be broken, yes or no? Right? Clear? Listen carefully. If the force of attractions were broken, now from the molecules here, rather than expanding, already some empty space is there na. These molecules are trying to occupy that empty space. If the molecules are occupying this empty space, now answer, is it contracting or expanding? Contracting. Why it is contracting? Already some space is there. These molecules are initially occupying that space. That's why what H2O between 0 to 4 degrees Celsius, it is contracting. From 5 degree, again they gain the temperature and they show the normal behavior only. But exactly between 0 to 4 degrees Celsius, this is what happening in ice. Because of hydrogen bonding, there are empty spaces created, and the molecules initially they are occupying these empty spaces. That's why they are contracting. Got the clarity about the point, students? Next, solubility. A substance is said to be insoluble in water if it does not form hydrogen bonding, right? Solubility. What's the meaning of solubility? Solubility a factor also based on developing the force of attraction. Sodium chloride added to water, how it is getting dissolved? Sodium ions are attracted towards a partial negative charge of oxygen, and chloride ions are attracted towards a partial positive charge of hydrogens. That's why they are soluble. That means, what's the meaning of solubility? Dissolving. What's the meaning of dissolving? They get into the spaces between the water molecules. How they can get there? Are they swimming? No, they're developing the hydrogen bonding. They're developing the intermolecular attractions. If these attractions are not possible, so do these molecules, can they dissolve? Can oil dissolve in water? No, oil also comes from these organic compounds. Like you can see, some examples are given. Alkenes are insoluble in water. So these, why? Because absence of hydrogen bonding. That's why when there is a absence of hydrogen bonding, they are mostly insoluble. If there is a presence of ionic nature, definitely they are soluble. So alcohol is also an organic compound, but alcohol has OH group, yes or no? So there is a chance for partial positive and negative charge, it will dissolve in water. But alkanes, alkenes, oils, petrochemicals, due to the absence of hydrogen bonding, they are insoluble in water. Like dissolves in like. Understood? Ionic character means it dissolves in polar solvents. Non-ionic dissolves in organic solvents, right? Next, metallic bonding. Metallic bonding is also significant bond. It is also not creating a new compound, but it is also an attraction, students. For example, we already know metals, right? What is the famous common metals? We know iron or gold, silver. We know all these are solid form. Do you know how do they exist at the atomic level? How do they exist? All these metals, they have valence electrons, yes or no? What is the nature of metals? Metals always show tendency to lose electrons. In the solid form, these electrons which are present in the valence shell, they are almost lost. Lost means they are not going anywhere. Surrounding these metal atom only, they are there, they are present. Surrounding this metal atom, but they are freely moving. If this electron was lost, that means which is out of its valence shell, the remaining atom definitely it will attain a positive charge or not. Look at the image. It will attain a positive charge or not. And look at these red dots. Red dots are like electrons. Electrons have negative charge, and this remaining metal atom with a positive, there is an attraction or not. This attraction is called as metallic bonding. I already have told you, are these electrons are attracted to only to one metallic atom. This metal atom with a positive charge are called as kernels, and these are electrons, and every kernel is surrounded by many electrons. It's not like this is my electron, this electron is mine. No, not like that. So that's why these electrons are freely moving. These electrons are also called as free electrons. Metals conduct electricity because of the presence of these free electrons. Simply they're moving in that position. Got the clarity, students? So this attraction between the electrons and the positive kernel is called as metallic bonding. A bond that holds metal atoms together on account of the force of attraction between the metal ions and the free electrons. What are free electrons? The valence electrons of metal which are in the lost condition in the outer shells of the metal atom is called as metallic bonding. They are associated with the metal atom only, but not only to one atom. They are like associated like a group, like a complete mesh kind of arrangement. So in the metal crystal, each atom is surrounded by 8 or 12 other atoms. That's what I said. Is it like one atom, one metal atom, one electron attraction? No, this electron is attracted by the surrounding metal ions, and these metal ions also show attraction towards the surrounding electrons. That's what the arrangement it is. So it is stronger than hydrogen bonding, but it is weaker than covalent and ionic. Covalent and ionic are purely chemical bonds. So here the main point is metallic bonding is stronger than hydrogen bonding. Hydrogen bonding is a weak attraction. So bond parameters, to study about the bond, to explain, to define the bonds, these are main students: bond length, bond energy and bond angle. So first, bond length. What is bond length? The equilibrium distance, that means the same equal distance between the nuclei of two covalently bonded atoms is defined as bond length or bond distance. That means look at these molecules are in the combined form. This is the nucleus of this atom, this is the nucleus of this atom. So the distance between these two nucleus is called as bond length. Sir, why? And what is half the distance of bond length? Is called as atomic size. Yes, sir, we already discussed. So this is called as bond length, and this bond length is different, students, for different molecules. Bond length is usually expressed in angstrom units or picometers. So answer, students, which has more bond length, like single bond compounds or double bond compounds or triple bond compounds? Single bonded compounds have more bond length, followed by double bond, followed by triple bond. Why? We discussed in VBT, valency bond theory. For the formation of triple bond, the overlapping of the sigma bond is more or not? If the overlapping is more, the combining atoms comes even more closer. So the bond length will decreases. Remember, triple bonds have very less bond length comparatively than double bond and single bond, right? Next, bond energy. What is bond energy? The amount of energy required to break 1 mole of a diatomic molecule in a gaseous state into their free atoms is called as bond energy. It is also called as bond enthalpy or bond strength. Bond energy is generally expressed at room temperature. The unit of bond energy is kilojoules per mole. So all these atoms, they form bonds. They develop the bonds. If you want to break that bond, sir, how to break that bond? We can break that bond by providing the temperature condition, thermal decomposition, by electrolysis, electrolytic decomposition, by sunlight, by photolysis. We can break the bond. But like there is some temperature requirement, yes or no, to break that bond. How much temperature is required to break that bond is called as, is given by bond energy, generally expressed in kilojoules per mole. So students, this bond, look at here, one example is given. Chlorine bond energy is 242 kilojoules per mole. Answer, which has higher bond energy? Single bond, double bond or triple bond? Triple bond has more bond energy than double bond. Double bond has more bond energy than single bond. Why? Because single bond contains one sigma bond which is stronger. Double bond also contains one sigma bond which is equally stronger, even more stronger. Why? Because of more overlapping, and it contains one extra pi bond. Now triple bond contains one sigma bond, yes or no? Definitely, which is even more stronger, and it contains 2 pi bonds. 2 pi bonds are weaker only, but is extra, right? We need to provide some energy for them also. So triple bond has more bond energy than double bond and than the single bond, right? Next, last one is bond angle. Bond angle is usually calculated, students, to identify the shape of these molecules, like the distance between, or the angle between two electron clouds of the two atoms which are bonded to the central atom. So the angle that is formed between two adjacent atoms bonded to the central atom in a molecule is called as bond angle. So look at here, carbon is bonded with 4 hydrogens. Where these four hydrogens are present, what is the bond angle between all these hydrogen atoms? So you know, between carbon and hydrogen there is a bond. What's the meaning of the bond? Electron cloud. So they can find the angle between electron cloud and electron cloud, so that we can identify the shape also. So here bond angle is generally expressed in degree or per minute or seconds. So for example, HCH, this bond angle in CH4 molecule is 109 degree 28 minutes, as well as in boron trifluoride between fluorine the bond angle is almost around in BF3 120 degree, and in ammonia in the case of 107 degrees. So what affects the bond angle? Why the bond angle is changing for different molecules? You know students, what affects the bond angle? The repulsions between electron and electron clouds. If the repulsions are more, then what will happen? Little bit they far away. If there are less repulsions between bond pairs and bond pairs, they come closer. Yes or no? Sir, why bond pair repulsions? There are one more pair of electrons called as lone pair we are going to cover in VSEPR theory, valence shell electron pair repulsions theory. So if lone pair repulsions are more, then what will happen? They will stretch the bond pairs a little bit closer or not? The bond angle will be reduced or not? So that's why the bond angle differs based on lone pair repulsions, lone pair repulsions, bond pair and bond pair repulsions also. So these are the main parameters to study all these, the bond strength and bond length as well as bond angle. So students, I hope you got the clarity in this video. So that's all for today.